Hi everyone, my name is Arthur and I work as a concept designer at LEGO Education, developing sets like Spike Prime, Spike Essential, and as you can see, I'm not at the LEGO office. I'm not in Billund. I am at home and this is my personal LEGO workshop. Here's the place when I have time, when I have free time, I like to build some cool stuff. My latest project was the machine that is able to stack house of cards up to 8 layers, 8 floors. So it was a really cool project, but it's not what I want to talk about it today. So some time ago, before the launch of LEGO Learning System, before the launch of Spike Essential, we already had Spike Prime on the market. I was talking to some colleagues and also with my manager, and we were trying to identify what we could build to showcase all the possibilities with Spike Prime and the new hardware that was about to come. And we had several ideas, but we were looking for something really special, something that we could do just with the new one. And you know that we have the new motor, the smaller motor, the small one. We have the large and the medium with the Spike Prime. We also have the new light matrix. So how we could combine all this stuff in one nice piece. So spending some time, I thought, okay, maybe we should build a humanoid. Everybody loves humanoids. I think we can do so many things with them. And just look into what Boston Dynamics is able to make with Atlas. So dancing and doing all this stuff. So get inspired by them. Say, let's try to build a humanoid. It's not the first time that I built one. In 2015, I built one using EV3, together with some colleagues from work. And it was a really cool project. It was a big robot with moving arms, moving shoulders. In that project, we were using an exoskeleton. So you wear the exoskeleton and it copies your movements. So it was really good. It works pretty well. It didn't have a lot of movement. It had it was concentrated on the arms and shoulders. So the head was static, the torso and everything was static. But it was really cool. I had plans for that robot, but I was never able to conclude that. But thinking about the Spike Prime, Spike Essential hardware, I thought maybe we have a different situation now because we can do other stuff that we were not able to do before. As you can see, the motors, they have this nice shape. So they are squared. It's a block that it's easy to understand, easy to prototype. There is a lot of building interfaces. With the old sets, normally you had to build a structure around it. Now we have like the small motor also. So we have a good range with different kind of features. So probably we can do something different for a humanoid. Probably because it will be smaller. If it's smaller, it will be lighter, and if it's lighter, it can be faster. And it's quite important to be like that. When you want to copy movements, you want to be strong enough to move slowly, but you want to also be fast enough to copy to be really natural. So you have different speeds when you are doing a movement. Sometimes you start slow, but during you fast. You speed up, so you have easy in, easy out. So it's quite important to create a nice natural movement. And another thing that I thought that could be interesting for this project is instead of using an exoskeleton, we could try to use animation software, a 3D software. I have a background of computer graphics, so I used to do a lot of animation, 3D modeling and things like that. And I know how powerful these systems are and these softwares are. And normally we call this digital twin. So imagine that I will build the robot, so the real LEGO robot, and I will create a copy of that in the computer, in the 3D software. I will animate the 3D model, and I will use all the tools because all the software, they have like several tools for animation, loops, You have graphs where you can edit the curves. You can create easy in, easy out. So it's much easier to control things, movements. And the idea is to transfer all this data, all the coordinates of the motors to the real robot. So it will copy. So it's a digital twin. They will be the same, but one is real and the other one is virtual. When I have a project like this, normally I start creating small sketches, small prototypes, like this one. So just a piece of paper, I draw some information that will help me. Sometimes I need also to communicate to other people what we are planning to do. But for myself, it's important. So here, like, I have a robot and I start to identify the kind of movements that I want in this robot. In this case, I have just an illustration about the arms, and I define that I want 4 motors. So one motor will be the elbow, so here. Another one will be a rotation, so it probably will be a turning table here doing this movement. And the other 2 will be allocated to the shoulder, so moving like this and like this, so 2 different directions. And the arm is quite important because probably it will be the place where I'm going to allocate, I will concentrate several motors. And it was probably the first part that I prototyped because depending on the size of the scale of the arm, it will affect the size of the robot. So I have here one of these prototypes. So as you can see here, we have like the shoulder of up and down. I have the other direction, of the other axis of the shoulder going up and down here, also moving forward and backwards. And in both situations I have gears. So here I have gears, and here I have like a lever with a rack, so going up and down. And it's important because like the arm is quite heavy, so I'm okay gearing it down. I'm losing speed, but I need to have that little that amount of torque. And here I have 2 essential the small motors, but they are connected directly. So I have 4 motors here. When I'm prototyping and I want to be fast just to see if things are working, I use the hard program on the hub. So probably this one is without a battery. Let's see if yeah, it's working. So I will connect here. Like I will move the shoulder so we can see going up, going down, going up, going down. Yeah, it's working. So happy with that. I can move to the other robot with the other motor. I do the same exercise, going up, going down. But what happens with the hard program? It works pretty well for continuous movement. When we want something that it's more controlled, I do something else, and I want to show you. Now we need to go to the software. So let's open our software here. So here it is. I will start a new project, and I will use word blocks. I'm fine with that. For this project, the final, it will be Python. But sometimes I just want to turn on a motor or do a simple code. I go to word blocks. That's what we are going to do. And the exercise is, I will have 2 motors. One will be my input, so I'm not using as a motor, just an encoder. And the other one is the motor that I will test. So I will move this one, and I want the other motor to copy this movement. So I will create a PID control. But here I'm not creating the full PID, just the P, just with the proportional. So to do that, we go to relative position. That's what I'm going to use. I will calculate the delta between them, so the difference between them. So let's say port B. I go to variables because I need one, make a variable, and I will call it delta. If you are talking about PID, this is the P. And set delta to this. I will make a loop. Let's connect our hub. And let's play, let's see. Oh, I need to connect the motors, otherwise it will not work. I need another motor. Where do I have it? Let's see it. So here. So as you can see, I have the delta working. So if I move just the A motor, you can see up here, delta will be the difference between them. I will stop them because now I want to have the other block that will be start movement, and here I will give my variable delta. I will place both of them, and let's just create some hand clocks here so everybody can see what's going on. Yeah, I will play. So I will move B, and A should be copying the movement. It's working, but maybe I want to be a little bit more precise. So this one should be faster. In this situation, I can just do a multiplier. So I will multiply delta. And here I can try different numbers. I would try 1.4. I know that this one will work pretty well. So they are moving, right? Now I can come back to my prototype and see how it will behave. So I will place here the shoulder. I can run the program, and here I can really see if it's moving. Yeah, it will be enough speed. Doing pretty well. Let's try to see the other motor. So, yes, it has a good speed. Maybe I can change the gears to speed up a little bit, and I have like this possibility. But for the prototype, it's good, so I can move forward. So, making this, I don't need to create the full robot right now, and I can test the small parts of it. So, the smaller prototypes, I can prove the concept, see if everything is working, and so far, looks okay. In the next video, we are going to move to the big robot, and we are going to see how to move forward with our project. So, testing the other parts, creating the virtual twin. So, see you there.